Ladies and gentlemen, this is a screencast about representing acceleration on a graph and in a motion diagram. Um, you're going to see a new graph here, a velocity versus time graph. So you need to pay particular attention to its meaning because it has a different meaning than the position time graph that you were exposed to in Unit 2. So let's review motion diagrams. Um, in this example, this shows a motion diagram for an object that begins um, on the left and moves toward the right. It's moving at the same velocity, and we know that because these velocity vectors are the same length. The one on the bottom, again, begins on the right, excuse me, on the left. This is the left. So it moves on the left, it begins on the left, moves toward the right, and those velocity vectors are getting longer, so we know that that one is getting faster. So the one at the top shows a constant velocity since it's covering equal distances in equal time intervals, and on the one on the bottom shows acceleration since it's covering changing distances in equal time intervals. This one happens to show getting faster since the vectors are getting longer. Okay, let's again do a quick review here. If we start with the one here on the top, assuming that the left is negative and the right is positive, if we start at position number 0, then we can see that these locations, 0 through 4, there's an equal change in position each time. So that shows us a constant positive velocity. This is moving this direction at a constant steady pace. The one below it begins on the right side and moves toward the left. And in these first 3 intervals of time, it moves equal distances. So we have a negative velocity from 0 to 3 since it's moving in the negative direction. And it's a constant velocity. Then during these last intervals, 4, 5, and 6, the change in position is not the same. So that's accelerating. The change in position is smaller. So we have a negative velocity, and it's slowing down. On the next one, again, we begin on the left. The change in position is not uniform. It's covering greater distances in this from 0 to 1 than from 1 to 2. So this shows an acceleration. It's moving in the positive direction. So this is an acceleration speeding up in the positive direction. From 3 through 6, however, the change in position is constant. So that shows us a constant positive velocity. This last one across the bottom, if we begin on the left, the first few intervals show that it's moving at a steady change in position. So this is going to be a constant velocity, and it's moving toward the positive direction. So this is a constant positive velocity. Then it appears to be covering different displacements. So during this last interval, this is going to be a constant positive velocity, but it's moving faster than it was before. This is an example of a video where we have something that is falling through the air. However, I don't think that the video is going to connect in the location where I am. So this would show something in free fall. So as it falls, it moves faster and faster. And this motion diagram tells that same story. And it has both the positions shown in red and the vectors for change in position shown in yellow. So we can clearly see that we have velocity that is increasing based on this motion diagram. Here's another example. So across the bottom in this GIF, we can see that this ticker tape dot moves across the screen, and it represents the position of the car shown above. And so at equal time intervals, it's covering greater distances as it moves from the left to the right. So that means it's accelerating since it's covering different distances. And since the distances are increasing in length, it's speeding up. It's moving in the positive direction. So we can summarize that by saying the car is accelerating or speeding up in the positive direction. So the next one shows a car that's accelerating or slowing down in the positive direction. So it begins at this position, moves in the positive direction, but it's covering shorter distances in each equal time interval. So if something moves a shorter distance, then we know that it's slowing down. So this car is accelerating or slowing down in the positive direction. So now it's time to look at these graphs. So this is an introduction to a velocity versus time graph. This is different than the position time graph that we studied in Unit 2. So just as a quick overview, the vertical axis on a velocity time graph is velocity measured in meters per second. The horizontal axis is going to be the time axis, and the unit will be seconds. So a velocity versus time graph, measured in meters per second for velocity and seconds for time. This red line across the middle of the graph represents how we would plot something that is not moving. This shows time passing, so as we move along this axis, time passes. However, velocity remains zero. So that indicates something that's plotted along this axis is something that is not moving. It's sitting still. All right, so let's look now at some generalizations about what we can say about the top and bottom halves of this graph. So if we look at the top half of this graph, anything that is graphed in the top half of this graph is moving to the right. It might be getting faster as it moves to the right. It might be getting slower as it moves to the right. But anytime you have a positive velocity, by convention we call the positive direction to the right. So that means that anything graphed in the top half of this velocity time graph is moving toward the right. Similarly, anything graphed in the bottom half of this graph where the velocity values are negative, that object is moving toward the left. It might be getting faster as it moves toward the left, or it might be getting slower as it moves toward the left. Okay, we're covering a lot of good stuff, so make sure you're getting these things in your notes. All right, on this next review, let's look at these blue lines. So in this case, this shows us a line that has no slope. So if there's no slope on the velocity time graph, then that indicates that's something that's continuing at the same velocity. Remember that a velocity time graph is a graph that shows how fast something is moving at a particular time. So in this case, for this line across here, as time passes, the object depicted by this blue line is moving at a steady 3 meters per second all the time as time passes. This one down here is moving at a steady -2 meters per second as time passes. So with that in mind, the one on the top shows an object that's moving faster than the one on the bottom, and they're moving in opposite directions, since a positive velocity is in the positive direction and a negative velocity is in the negative direction. Then the other thing that we can find on a graph like this is when velocity changes. Remember, these two lines show us that velocity is not changing. Position is changing. The object is moving, but its velocity is staying the same. So these blue lines show something like cruise control on the car, moving at a steady, constant pace. However, when we get lines that look like this in green, that shows something that is not moving at a steady pace. These green lines show something where velocity is changing. And from our last video, we know that when velocity changes, we have acceleration. So anytime on a velocity versus time graph like this, if you have a line that slopes up or down, then that indicates to you that the object is accelerating. Its velocity is changing. Let's look at that in the next example. What would be happening here with this pink line? So let's start at the beginning. We have a beginning velocity of a -4 meters per second. So this thing is moving in the negative direction, so you can think of it as moving backwards at 4 meters per second. Then later, at this time, the velocity is 0, so it stops. So it's moving backwards, then these velocity values are getting, the magnitude is getting smaller and smaller. So it's getting slower. So it's moving backwards and then it stops. Then later on yet, its velocity is a +3. So remember, positive and negative velocity indicates different directions. So this is showing something that's moving. Uh-oh, sorry, I'm in an airport and they just came on the intercom. So give me a second for this to pass. Sorry. Okay, So what we know is happening here is that we have something moving backwards, stopping, and then speeding up, going back the other way. So this shows something that moves backwards, slows down, stops, and then speeds up going forward. Wow, that's kind of a complicated graph. But if you just slow down and look at this carefully and read over and kind of compare as you move up this graph, it makes sense as long as you're remembering that a negative velocity and a positive velocity indicate different directions. All right, so as a summary, lots of things here to keep in mind. A velocity versus time graph shows how velocity changes with time. A velocity time graph can show that an object gets faster, gets slower, or stays the same velocity. So the orange line shown on this graph shows something that is getting faster. So in this case, velocity is changing. We have a 0 velocity and later a velocity greater than 2, so this got faster. This line down here shows a starting velocity of -2 and later a velocity of -5. This one got faster as well. The difference between these two orange lines is that this one shows something that is moving in the positive direction as it gets faster. This one is something that's moving in the negative direction as it gets faster. Let's look at the green lines now. The green line shows something that's getting slower. So for this line right here, this is an example of something that starts at 4 meters per second and goes to 0 to stop. So this one's getting slower as it moves in the positive direction. The one down here is moving in the negative direction and gets slower as it comes to a stop. Remember the red line, this flat line at 0, means the velocity is constant and 0. This red line means the object is not moving at all. The blue lines, however, so the blue flat lines show velocity is constant, but it's not 0. So when we have a graph shown by these two blue lines, the object is moving. So at a positive 3 meters per second, it's moving in the positive direction at a steady pace, or at -2 meters per second, it's moving in the opposite direction at -2 meters per second at a steady pace. All of these lines show something that is moving except for the red line. The red line shows something that is sitting still. Bear in mind as well that anything that's graphed on the top half of this graph is moving in the positive direction. Anything that's graphed on the lower half of this graph is moving in the negative direction. Okay, lots of stuff. Good luck. Do some good practice so you'll be ready to interpret graphs correctly.